hydrogen is used up, the core gets denser and hotter, allowing the helium nuclei to fuse into another heavier element, beryllium. Again, the temperature of the core rises and the beryllium begins to fuse with the helium into carbon. Fusing carbon raises the temperature of the core again. Under the pressure, the new elements start to fuse with each other and with the hydrogen. Many of the elements we know today are built in a star's core. Finally, an element we call iron is made. But the nucleus of iron is so stable that it can't fuse, and so temperature is no longer increased into the core. Suddenly, there is not enough pressure from inside the star to balance out the gravity equation. Gravity wins, but the core of the star collapses. Russian gravity slams the atoms against each other with such force, the star blows itself apart in a supernova.
Excuse me, mister.
Yes, young lady.
What is a molecules?
Good question. Let's go take a closer look. These are some molecules found in a nebula.
Ooh, molecules.
A molecule is a group of atoms linked up together like they're holding hands. You have this molecule in your body, and it's found in this nebula. It's water. A water molecule is made by one oxygen atom linking with two hydrogen atoms. You might recognize its chemical name, H2O. Another common molecule in a nebula is carbon dioxide, CO2, made with one carbon atom and two oxygen atoms. Your body produces carbon dioxide and you breathe it out. You all make this molecule too, except you don't breathe it out. Any ideas what it's called? Anyone? Thank you very much. But all I was after was the word methane.
You made a methane.
I hope not. When it comes to atoms in your body, carbon atoms are the most important. You see, carbon can bond with up to 4 different atoms at once, making it possible to create really interesting molecules. By linking it up with atoms like oxygen, hydrogen, and nitrogen, carbon easily makes some familiar molecules, like sugar molecules, fat molecules, and a vital part of protein molecules. Unfortunately, these molecules are quite fragile, and the radiation of space easily breaks their bonds. So we need to build somewhere that's protected and big enough to collect plenty of molecules. Somewhere like a planet.
गजब देखो पानी गिरेगा ऊपर से अरे बाप रे उदाऊ गलो.
This giant disk of gases, molecules, metals and dust is our solar system. And At its center is a very young sun. Within these churning clouds, gravity is pulling these molecules into great spinning masses that will become planets.
आगे हम बड़ा बड़ा पहाड़वा
For over 100 million years, leftover dust and blocks of frozen gases relentlessly bombard the young planet. Each impact melting the surface and filling the atmosphere with molecules of carbon dioxide, methane, and ammonia.
आगे मैं यार क्या पे गिर तू छोटका आ रहा जो ए हे गिल
slow down and the surface begins to cool. The steam in the atmosphere turns to liquid and it begins to rain. It rains for thousands and thousands of years, eventually covering the whole earth in water. Under this ocean, a new stage in the journey of atoms and molecules is beginning. Water, heated by the molten rock of the Earth's mantle, bursts through vents in the Earth's crust, dissolving molecules along the way. As it meets the cool water of the ocean, these minerals are deposited, forming towers. As the molecular mixture passes through the mineral-rich chambers, they start to form the molecules we call the building blocks of life. Perhaps it was inside a vent like this, following hundreds of millions of years of chance interactions, that molecules formed the first life in the shape of cells. Under the ocean, these first cells use the molecules and atoms from their environment for energy and growth. It wasn't long before they began to make copies of themselves. Suddenly, there were hundreds, thousands, millions, trillions of cells spreading throughout the oceans. 1 billion years of random mutation resulted in a startling advance. Some cells began to use the sun's energy to turn carbon dioxide and water into sugar. This superpower, photosynthesis, let cells grow much more quickly. But a nasty surprise was in store. These new supercells released oxygen, and as this built up in the atmosphere, it changed our planet forever. Highly reactive, the oxygen poisoned a huge number of cells, causing a mass extinction. But some cells survived. As they replicated, they filled the world with cells able to tolerate or even use this new gas. And life sped on. Some cells began to work together and form groups until they had become the first multi-celled organisms. Over many generations, their forms slowly changed. Some of the original microscopic molecule factories had evolved into simple worms. It wasn't long before the worms evolved into primitive fish. Using iron in blood cells to capture oxygen and calcium to build bones, the fish continued to evolve and dominate the oceans.
डायनासोर
Over time, the molecules and atoms are constantly being recycled and modified as they pass from one living thing to another. Above the water, plants and giant insects took over the land. But they were soon followed by fish that had evolved the ability to crawl out of the sea and to breathe the oxygen-rich air. These oxygen breathers evolved into reptiles, which became the dinosaurs. And for over 100 million years, dinosaurs dominated the Earth, the masters of molecules, until... the giant impact changed the environment so rapidly that many forms of life were unable to survive. The age of the dinosaurs came to an end. But some species did survive. With the dinosaurs gone, mammals evolved to take their place as the new top atom organizers. Through the process of natural selection, they adapted to new habitats. As species died off and new ones flourished, a tree of life mapped out the generations. Then millions of years later, on a distant branch of the family tree, there grew a new branch of mammals, the apes. Many generations later, on a twig from this branch, there stood some very strange apes. These apes were strange because their atoms had formed brains that didn't just think simple thoughts like, I'm hungry, but complex ones like, what are we made of and where did it all come from? They have been finding out the answers ever since. We have discovered that we are made of atoms, and these atoms are on a journey as old as the universe. Before they became part of you, they were in animals, plants, and in the air. They were once in dinosaurs, in primitive fish, and made up the very first cells. Cells assembled from molecules containing atoms that first arrived on Earth as comets and asteroids. Born within the clouds of giant nebulae containing complex atoms, delivered by exploding stars. Atoms that have been fused by gravity deep in the core of the stars. Stars that were formed from giant clouds of hydrogen. The same hydrogen that was the first relationship between a proton and an electron. But it all started when energy came together to form matter after the universe expanded from a single tiny point.
खत्म
Roll up for the greatest show in the universe.
ये हुर्रा पूरा बेकार देखा